title of the paper, next paper is the cooling characteristics of refrigerated vehicle using thermal storage material. So it will be presented by Mr. Maulana Rifaldi from the Chonnam National University in Korea.
I will present the presentations, the title of cooling characteristics of the refrigerated vehicle using thermal storage material. My name is Maulana Rifaldi from Chonnam National University, South Korea. This is the content, introduction, experimental apparatus and method, experimental result, and conclusions. Firstly, the introductions. As the report from the IIR 2007, more than 1 million refrigerated load transport and 850,000 refrigerated containers are in service in the world. And MOMAF report 2006, 2.7 million tons of Korea fishery products and more than 5,000 billion won cycling in this field. Refrigerated transport form an important part of the cold chain system for such raw fish products and the issue of energy efficiency as well as environment concern of refrigerated transport system. Next. The background of this study. First is as we know, in the evaporator, sometimes ice is formed, or we call it frosting in the coils. So it is reduced heat exchanger performance. It is we use reverse cycle hot gas defrost system with thermal storage that already maybe presented by previous presenter, that we use phase change material. We will find the cooling times and defrosting time down, cooling down time, which is will give saving energy. So we will get the characteristics of the refrigerated vehicle system using thermal storage. In this slide, I will explain about the operation on refrigerated vehicle. In the left side, this is a general cycle that we already know. From compressor will produce high pressure and high thermal. So the refrigerated cycling from compressor to condenser and then receiver, and goes to the evaporator and return to the compressor. But in few hours, the ice will form in the coil of evaporator. So this is the pictures of the cooling operations. As the previous slide, I already give you that this ice will reduce the performance of the evaporator. And then the right side is hot gas defrost operation. So after from compressor, the refrigerant goes directly to the evaporator, and then by doing the best pass, the condenser, receiver, and filter. So with this cycle, the ice in the evaporator will be melted, and return, the performance of the system will return. In our lab, we made a prototype design. This is our dimension of refrigerated vehicle with a length of 3,235 millimeters and width of 1,740 and a height of 1,640. After we make the design, so we made the prototype. This is the prototype of refrigerated vehicle container constructed for laboratory. We make the scale of the container prototypes similarly with the actual dimensions of the refrigerated vehicle in the regular operations. The scale is 1 by 1. And we make a heat storage system. In the left side, this is thermal storage we made with contain 2 rows, and each row has 4 circuits. Is made of copper tubes with the size of thermal storage 400 length, 800 width, and 300 height. And the second one is made of aluminum thin tubes. This we made 2 kind of heat storage, and then we make the conversion. This one is the pictures when the installation on the refrigerated vehicle for thermostatic size raw fish. Not only at the laboratory we made the test, but we also made in the real condition. But in this presentation, I not give about the test in the world. This is our experimental facility. First, this the prototype that we made in our lab with the same scale with the regular operations. And the compressors, this is our compressors, and the evaporator inside the box. So, and this is the condenser, and then we make the thermal storage in here. All the pipe is insulated very well. So, and then this computer is for the data acquisitions. This is the experimental facility that we made in our lab. First, the compressor with 2000 RPM and displacement 147. Refrigerant, we use R404A, evaporator made of aluminum tins, and condenser also made of aluminum tins. The expansion valve, heaters, we use heater for load operations, and then the thermal storage, fin tube and copper tube. This is the thermal storage properties. We use 2 kind of thermal storage properties. First is paraffin, and second is we using water. Paraffin, we choose paraffin because the phase change thermal material with the thermal conductivity half of the water, and has a specific heat in liquid and solid, and the heat latent about 175 kJ per kilogram. This is the result of our this is the experiment that we made in our lab. Firstly, we make the parameter of cooling down time, and second the defrosting time. SGD 0